Like I said, my name is Anoop Sattineni. Tony Cady was a graduate student of mine. He did this research along with another faculty member at Auburn University in Alabama, Junshan Liu. Both of them are not here. So today I'm going to talk to you a little bit about, really this is a story about people. It's not really about Scan-to-BIM as much as it is about how people adopt technology. So I'll skip over some of this since we only have about 6 minutes. I'll talk more about the beef of what I want you to remember, or at least hear. No, that's fine. That's fine. Don't worry. Tony worked for the Army Corps of Engineers. The Army Corps of Engineers in the United States it's one of the largest really construction organizations in the world. There are about 37,000 people. They are pretty much all over the world. Anywhere the U.S. Army has a footprint, they have these engineers who are responsible for construction, maintenance, what have you, of facilities. They also have an enormous footprint within the United States. They're responsible for the waterways within the United States, which transport a lot of goods, and then also the shoreline of the United States. They're responsible for rehabilitation and that sort of thing. Suffice to say, it's a very large organization. And this project is one of their first projects of using a laser scanner or LiDAR to capture data for renovation projects. This particular project was done in the Savannah district. They're sort of broken down into 9 divisions and then more than 50 districts all over the world. But this one was based out of Savannah district in Georgia. Part of the core is that they also have in-house design teams. These are designers that are responsible not for all their design projects, but anything that they deem is not extremely high value or high risk, they tend to do their in-house designs. Anything that is sort of a larger project, then they may decide to go a different route, like a design build firm or something along those lines. So this particular topic, what Tony was trying to do was to implement or purchase new equipment and then start using it and then try and figure out what did we learn here and what can we share with the rest of the core. And then, the core being an organization so large, it obviously has a lot of inertia to overcome anytime they take on any new technology. So some of his experiences talking to these folks are sort of captured in this. I'm not going to spend too much time on all this. I think everybody in this audience, at least, for sure knows everything or a lot of this information already. Tony went about doing this research as a case study because he was particularly interested in documenting sort of one building where they used traditional methods of capturing data, and then another building where they used the sort of LiDAR scanning to capture the data. Both of those buildings were ready for renovation around the same time. And then he sort of obviously adopted a qualitative approach to the study. And these are several of the data sources that he captured and looked at. Obviously, when it comes to using a scanner, they had to spend some money to purchase the scanner. But before they did, we convinced them to actually use our university scanners to try to figure out sort of what works for them. And we were able to give them a gamut of, these are in the market and capabilities and whatnot. We used the Faro scanners for this particular project. We used 2 of them. One is the Focus and one was the X5, I believe. This particular project, so these are the 2 buildings we looked at, 315 and 317. 315, the data was captured in the traditional way of sending out architects to the project. Again, these buildings are about 1965. They're on Fort Gordon, which incidentally is going to be renamed Fort Eisenhower shortly. So 315, they sent out architects to these essentially dorms for the medical personnel for the U.S. Army. This is one of their training centers, and these are dorms when they're training there, they stay there. So both buildings are ready to be renovated. The 315, they sent out architects to capture the data, and then they sort of kept track of how much time it was taking them, what are the different things that they're learning as they're going through the design process. Nowadays, the Corps has switched over to using BIM as a primary design tool. So these architects are very familiar with BIM and using various products related to that. And then 317, we captured using LiDAR data. As we were doing the field study, all the different areas we scanned, both interior and exterior. And anybody that's ever done scanning knows the importance of field notes that you've got to keep as you're going through this. And then we captured the raw data for the point clouds, and then obviously processed it and then cleaned it up using Ferrocene. And then eventually those were used to produce construction drawings for release for bidding. Both of those buildings. So again, this was the workflow, if you would. And then as he was doing this, again, this was about over a 9-month period that this happened. He interviewed about 13 people, mostly semi-structured questions, apart from all the other data that he captured. Again, this was Tony worked for the Army Corps of Engineers, so he was in the Savannah district. He's not an architect, but he's a program manager, and he had access to all the people. And these are the people that were involved in the interview process as far as who he talked to. Most of them, everybody that was involved on this project, as far as design went, were people that he interviewed. And apart from that, he interviewed a few other people from other places within the Corps. Particularly, he interviewed folks at ERDIC. ERDIC is, the Corps has their own internal research organization. Well, they have several. One of them is ERDIC, which is there for design and construction, specifically related to technology. And based on the interviews, he did some qualitative thematic analysis and content analysis, and then came up with some major themes that he discovered, which was looking at how current data is captured, what are the challenges in Scan-to-BIM, and future use cases, and then obviously benefits. Again, looking at benefits from within the Corps, from inside the organization. When it came to current data, there were several things that he found during the process. For one, we had to send back architects a couple of times because there was some data that was not captured that we didn't realize until we started the design process. And then obviously there's time, there's obviously cost of travel, that is people sending back and forth. And then of course, you also have issues related to accuracy. Human beings make errors, and there were not a whole lot, but there were a few that we found that were different from what were the actual site conditions than what was recorded. Challenges as far as what we learned, what he learned about, what the design team learned about sort of using this technology. Same thing that all of us already know, which is there's enormous, obviously there's a cost associated with the equipment, there's cost associated with training, and the capability of the personnel involved largely dictates the success of the project. It's not because the technology is not there, but technology is constantly changing. People are not always current. People have to be trained in the first place. All those things he learned. He also learned how accurate it was, obviously. Things that are occluded that we can't see behind the walls, above ceiling tile, those kinds of issues exist no matter what type of data capture you're doing. And then for within the organization, he found a lot of benefits. Again, these are benefits that are well documented in the industry already. Uh, but these are things that they thought it was significant enough for them to invest in this technology. Again, as I mentioned, the Corps is a rather large organization. So if they decide to adopt this technology, you're talking about millions of dollars that they're going to spend purchasing equipment all over the world. And this is one of their first projects. And by and large, everybody on the project agreed that this is really the future. This is what we need to do in future projects. And one of the things that they found, that they didn't capture in the original or the manual data capture was there were many of the floors that had a significant deflection that was not captured in existing sort of manual measurement, if you would, and that called for structural enhancement. Again, it may not seem like a big deal, but it's really a big deal when it comes to the Corps because all their projects are approved at the federal level. So if you want to go back to ask for more money, all of a sudden now Congress has to get involved. Anytime Congress gets involved, it's a crapshoot as to how long it takes to get the approval process and whatnot. So enormous pressure in order to execute the project to get this data correct, especially renovation projects. And that's where they found that the accuracy part sort of supersedes everything else. And especially given that they have a life cycle of about 3 to 5 years for this equipment. And they think that's a worthwhile investment for them to continue. So finally, some conclusions. Again, they've concluded that it will improve efficiency. They have a lot of advantages. There are still some challenges associated with Scan-to-BIM. Obviously, it's not automated, or at least there's some parts that are automated, especially if you're looking at MEP rooms and that sort of thing. There's a lack of standardization within the industry as to how we go about this. That was one of the challenges they've identified as, if you're going to do this, we got to have a method to the madness as to how we do this between all the districts, just so that we're following the same procedures. And they think the return on investment justifies their investment in scanning technology to capture existing data for renovation projects. I think I didn't hear the second bell, so I'm saying I won.
All right. Thank you very much.
Thank you.